Hi guys and girls, a video here on binomial expansion. Now you did meet this, or should have met this, in your first part of your A-level. However, I am moving on to the part that is in the second half of A-level, or year 13. So if you're looking for year 12 stuff, this is not the video for you. If you're staying for the year 13 stuff, then hopefully you should know this formula here. It's one that you are given on your formula page, and you will be given the new version on the year 13 formula page. This one here only works if n is a positive integer. This is what this bit here means. If n is not a positive integer, then you can't enter this into your calculator. It's impossible. It just goes math error, no. So what we have to do is, if we want to do anything, any expansion that doesn't have a positive integer, for example something to the power of a half or to the power of -2, that kind of thing, we can't use this formula. What we can do is, this formula here actually stands for this calculation. So n-1, n-2, and it keeps going down, n-3, all the way down till you get to 1, over r factorial. In fact, r factorial means r minus 1, r minus 2, all the way down to 1. That is what your calculator is doing when you shove it into your calculator. Now, we're going to do it by hand because we can't put it into a calculator if it's not a whole number, or a positive whole number, I should add. So the formula now becomes, for the new expansion, so we've got a plus bx to the n. Oh, another thing is it only works if a is actually 1. So what the first thing you're going to have to do is take out a factor of a to the n, which means you're going to get 1 plus b over a x to the n. Okay. So your formula now becomes, so the a to the n stays on the outside. The rest of it I will just do as the normal part of the formula. So it's 1 plus bxn plus n minus 1. So that comes from the formula n1. And this part comes from n0. Over 2, sorry, didn't finish that off. And that is b, or b over a, I should say, x squared. Then the next one is n minus 1, n minus 2, over 6. Again, that one comes from n3, and the 6, it actually comes from 3 factorial. The 2 is from 2 factorial, and there was effectively a 1 under here because that is from 1 factorial. So I'm just telling you where all these come from. And that is multiplied by b over a x, all cubed. And that carries on. Now it's unusual for them to want you to go any further than that. Like I say, it is a formula that you are given. Quite often though, they won't put the a to the n out the front of it, they'll just give you that part. You are expected to memorise the fact that you need it to be, in your bracket, you need it to be a 1 here. Okay. Let me show you by example. it will be a lot simpler once you get some numbers into it. Oh, and if anything mentions about validity, it's valid when b over ax modded is less than 1. So if you have to substitute any values in, as long as b over ax is less than 1, then it's a valid expansion. Again, I will show you what that means later. Okay, so an example. Expand the first 4 terms of, we are going to do 4 plus 3x to the half. Okay, so I can't have it as it is because it's got a 4 plus. I need it to be 1 plus. So what I'm going to do is take out a factor of 4 to the power of a half. So now I have 1 plus 3 over 4 x to the half. Okay, so I've taken the 4 out and just put the power on it, basically. Now, the 4 to the half has got to stay out the front. Now comes the substitution into the formula. So the first part is 1, it's always 1, plus bxn, so that's this bit, with an n in front of it. So 3 over 4, well we know n's a half. I'm going to put my x at the end. Then the next term, the third term, is n times n minus 1 over 2 times b x squared, or b over a, sorry, x squared. How many terms have I got now? 1, 2, 3. I need one more term. So that's n minus 1, n minus 2 over 6, b over a, x cubed. Okay, that's as far as I'm asked to go. Right, let's leave that. Oh, I could change that to a 2, couldn't I? Because that's the square root of 4, so that's 2. So I've got 1 plus. Now let's tidy up. We've got 3 over 8 x. I'm not going to put the minus there yet. From here, I've got a half times a half, which is a quarter. Divide that by 2 is an eighth, but it's actually a negative eighth. Times, and then if I square this bracket out, I'm going to get 9 over 16 x squared. It's very easy to keep putting pluses. Right, if I tidy this bit up, I've got a half times 3 over 2. So the top's going to be 1 times 1 times 3 is 3. And that's going to be positive because you've got 2 negatives. And then 2 times 2 times 2 is 8. And then divide that by 6 is going to be 48. Times, and if I cube this out, I'm going to get 27 over 64 x cubed. So tidy up further. So 1 stays as it is. The 3/8 x stays as it is. This here, can I cancel anything out? No, so that's 9 over 128. My pen will let me write 128. X squared. Plus, then tidy up this. What can I cancel? Not a lot. So I've got 3's. Oh, I can do 3's. This and this make 1/16. And that's about it, I believe. So it's going to be 27. You've got calculators for this. Well, 64 times 16 is 1024 x cubed. Okay, so I've tidied up the inside of the expansion as much as I can. So the last thing is to multiply through by 2. So I get 2 plus 3/4 x minus 9 over 64 x squared plus 27 over 512 x cubed. There is my 4-term expansion, all tidied up. Once you get it into the substitution, it is just a case of boiling things down. And don't forget, you've got a calculator for these. I've done all of this in my head. You don't have to. Okay, I've got one more for you. Actually, what I'm going to do... Hang on, just 20... but one sec. No, I just doubted myself for a moment as to whether the 27 over 512 would cancel, but it doesn't. Right, okay, one more. If my screen will move, there we go. So, I'm just going to concentrate on find the expansion. To the x squared term of, and this time we are going to do x plus 1 to the power of negative 3. Right, so it's a plus 1, so I haven't got to take anything out. I've just got to substitute it into the formula. Actually, that might be too simple. Let's make that a 7 so that we can practice both tasks. So I need it to be an x plus 1 or 1 plus x, doesn't matter which way around it is. So I need to take out a factor of 7. So 7 to the power of negative 3. Then I get 1/7 x plus 1 to the power of negative 3. So again, the 7 to the minus 3 is going to stay outside the expansion for now. So it's 1 plus 1/7 times n, and then put the x on, plus n times n minus 1 over 2 times the x term squared. Now I don't need to go any further because the question just said to go to the x squared term. So we get, tidying up, 1 minus 3/7 x. We've got a minus and a minus, so we're going to get a plus. The 4 and the 2 can cancel to 2, so that is going to be 6. And then times by, if you square this bracket, you're going to get 1 over 49 x squared. Tidying up one step further, so I get 1 minus 3 over 7x plus 6 over 49 x squared, and 7 cubed is 343. So I'm not going to divide through by 343. I'm just going to write it as a fraction. You could absolutely simplify that through, okay, if you needed to. So the last thing they could do is ask you to estimate something. So say estimate 7.6 to the power of minus 3. Well, you know you've just expanded x plus 7 to the power of minus 3. So x must be 0.6 to make that bracket 7.6, and you sub that into there. That'll be your estimation. Anywho, catch you later. Bye!